I am Anil Kumar. Welcome to my series on solved test papers. I have taken up many important test papers from previous years to share with you so that you can practice and get better marks. Let me thank all my students for sharing these test papers with me. In this video, we'll discuss a test paper on calculus where we have trigonometry and its applications. So let's go through these questions one by one. You can always pause the video, copy the questions, try them out, and then look into my suggestions. Now this test paper may take about an hour since I may like to explain you a few points in between. So once you know the technique, you should be in a position to solve this 75-minute test paper in less than an hour. Question number 1, differentiate the following, simplify fully. That it's important to simplify these given functions. Question number 2 is just to find the derivative of a composition of trigonometric functions. Question number 3, using second derivative test, determine all local extremas, maximums and minimums for the given function in the domain 0 to 2 pi. Now question number 4, determine the x-coordinates of all the points where slope of the tangent line for the given curve is horizontal, that is, slope is 0. Question number 5, if y equals to sine x over x, show that x d2y dx square plus 2 dy dx plus xy equals to 0. Now this is a very lengthy solution for this one, so you may have to take 5 minutes to solve this question. Question number 6. Determine the equation of the normal to the curve square root 2 sine x plus y equals to 0 at 0 pi by 4 expressed in standard form. The equation of normal, right? So it is based on implicit differentiation, right? Now here are other application questions. Question number 7. An observer watches a rocket launch from a distance of 4 kilometers. The angle of elevation theta is increasing at pi by 40 radians per second at the instant when theta is pi by 4. How fast is the rocket climbing at that instant? Question number 8. The depth of water D in meters of a seaside pier can be modeled by the function d of t equals to 3 over 2 cos pi t by 6, where t is time in hours. Determine the rate of change of the depth of water with respect to time at 3 hours. Question number 9. A particle moves along a line so that at time t in minutes, its position in meters is s of t equals to 8 sine 2t. For what exact value of t does the particle change direction in the interval 0 to pi? What is the particle's maximum velocity in the interval 0 to pi? Now when we talk about maximum velocity, you need to actually show it as we do in calculus, right? So that is kind of important to understand. So I hope you understand all these questions and you find them useful. Feel free to pause the video, solve them while we go through these solutions, correct? So let's begin with the very first one, which is to differentiate the following functions. So I've changed it a bit. So I'll be only simplifying part A and B. So I have part C and D I've clubbed with the second question. Okay. So let's see how to differentiate and simplify. You need to review trigonometric identities and all the formulas which you have learned to do this paper. So that is kind of very important for you to understand, right? Now we have this function which is f of x equals to 2 sine square x minus 2 sine to the power of 4x. We need to differentiate, that is to say f dash x. So we can use the chain rule to differentiate, correct? So the first term, it is 2 times 2 sine x times derivative of sine x, which is cosine x, correct? Minus here 2 times 4 sine cube x. We have used the power rule, correct? Times derivative of sine x, which is cos x. Now 2 sine x cos x is sine 2x. right? So we could write this as sine 2x. Or what we can also do here is that now this second part, which we have here as 2 times 4 sine cube x times cos x, we can actually take cos x common, right? So let's do that. So what we will do here is, to simplify, we'll take sine x cos x times 2 as common, right? So we can take 4 also, right? So we can take 4 times sine x cos x as common, and we're left with 1 minus. So we've taken 4 outside, 2 sine square x, right? So cos x has been taken common. Now 2 sine x cos x is sine 2x. So we could write this as 2 times sine, or let me write like this. Okay, just going through these steps. Now, what is 1 minus 2 sine square x? 1 minus 2 sine square x is actually cos 2x. So I hope you remember these formulas. That's kind of very important. So let me write down these formulas here before I write down the final solution. So we have cos 2x equals to cos square x minus sine square x, which could also be written as 2 cos square x minus 1, and it's also equals to 1 minus 2 sine square x, correct? And sine 2x is 2 sine x cos x. So we are going to use these formulas, and that's why I was just breaking it down into sine 2x cos x. So now I will write this as 2 times sine 2x, correct? And this term here, 1 minus 2 sine square x, is actually cos 2x. So what we get here is 2 times sine 2x cos 2x. So I hope you understand and appreciate this part, correct? So simplification is key in this particular question. Derivative may be simple, right? Now let's do the derivative of this particular function. Now let's say g dash x. You could actually simplify this and then do the derivative. So you could do that also. So some of you can actually simplify the function, write this as sine x over cos x times cos x, and then you are left with sine x, correct? So you could say g of x is sine x, and therefore the derivative of this function is basically cos x, correct? You could do that. But many of you will actually apply the product rule to do the derivative, correct? So let's do the product rule also. So tan x derivative is secant square x. So we can say g dash x is equal to, okay, so secant square x times cos x plus tan x times minus sine x, correct? So that is the derivative of cos x. Now secant square x is 1 over cos square x times cos x plus tan x is sine x over cos x. And this is, I should have written minus here. Okay. Now as you can see, one of these cos cancels. We have cos in the denominator, and the numerator is 1 minus sine square x, correct? Over cos x. Now 1 minus sine square x is cos square x over cos x, and that also gives you cos x. Perfect. So the derivative for this function is cos x. You get the idea. So the key here is to differentiate and simplify. That's what I want to lay more stress on. Now let's look into the other 3 examples where we are going to use different rules to find the derivative, correct? Now here, the derivative of the function will be 2 times sine square root t, right? We are differentiating with respect to t this time, times the derivative of square root t, which is 1 over 2 square root t. Correct? Times the derivative of the sine square root t, right, which is cos square root t. Do you understand this part? So what we have to do is to find derivative of inside functions, and we basically have applied the chain rule to solve this, right? So I'm giving you in short just the kind of solution to it, right? So 2 and 2 we can, or we need to simplify. So sine t is cos t square root t. We can write this as sine of 2t, right, when you simplify. Is it okay? So we could write this as this numerator as sine 2 square root t over 2 square root t. Is it okay? Now you may rationalize and also write, you could do that, but I have really removed that part here, so I written do not simplify. But you should practice how to simplify and write down your answers. So I hope you get the concept, correct? So that is how we could work with it. Now here we'll apply the quotient rule. So we get in the denominator 6x whole square, which is 36x squared. Derivative of this part, which is 4 cos cube 3x, times derivative of cos 3x, which is minus sine 3x, times the derivative of 3x, which is 3, right, times 6x, which is 6x, minus derivative of 6x, which is 6, times cos to the power of 4 3x. Is it okay? Right. So I'll leave the simplification for you to do on these questions, correct? The last one here, I should write y dash equals to. Okay. Now the derivative of this function f dash x. Now in this particular case, we have to work inside, right? So sine of all that will be, derivative will be cos of all that, which is cos of x squared. Perfect? Now, times the derivative of inside function, which is cos x squared, right? So cos x squared derivative will be minus sine x squared, right, times the derivative of x squared, which is 2x. You get the idea. So that is how you have to find the derivative. So this time we had a chain rule. Perfect. So you may simplify these questions, solutions, right? Here is question number 3. Now we need to use the second derivative test and determine all local extremas. So local extremas means what? We have to equate first derivative to 0, right? So first derivative for this function will be cos x minus, now cos x derivative is minus sin x, so let me write this as sin x. Derivative of 6 is 0. Now for extrema, what should we do? We have to equate the derivative to 0. So we get 0 equals to cos x plus sin x. So that basically means that we can write this as sin x rest, that means tan x, right? So let's write this. Sin x equals to cos x. Now dividing by cos, we get, if I divide this, let me show you here. Minus, right? So if I divide by cos x both sides, in that case, what do I get? I get tan x equals to minus 1, right? So in this interval, 0 to 2 pi, tan x is minus 1 in quadrant 2 and 4, right? So we get the value of x, which is the acute angle here is pi by 4, right? So this is pi by 4. So this is 1 pi by 4 to 3 pi by 4. Correct? 4 pi by 4, 5, 6, 7 pi by 4, or 1 less than 8. So these are the two critical points which we get. Right? So when we say using second derivative, determine all local extremas. So we could have actually also find the value from here. We know the critical numbers are at 3 pi by 4 and 7 pi by 4. But since the question says using the second derivative, so we have to find the second derivative, correct? So let's find the second derivative, and we get minus sine x plus cos x, correct? So equating now second derivative test. So in second derivative, we have to check these two values. So let's write down the critical values. That are at x equals to 3 pi by 4 and 7 pi by 4, correct? Now, which is in quadrant 2 and in quadrant 4, correct? So let's check the second derivative. So at minus sine 3 pi by 4 plus cos 3 pi by 4. Now, in second quadrant, sine is positive, so you get 1 over square root 2, okay? And for cos, it is negative, so you again get more negative, correct? So we know this is less than 0. So that means the second derivative at this point, being less than 0, is concave down, right? So this is concave down. So that means we have maximum at 3 pi by 4, correct? You get the idea? That is how you're going to do. Now let's test the other point, which is 7 pi by 4 in the same derivative. So minus sine 7 pi by 4 plus cos 7 pi by 4. Now 7 pi by 4 is in quadrant 4. Here sine is negative, so negative will make it positive. We get 1 over square root 2, and cos is positive, so we have a value which is greater than 0. Since it is greater than 0, in this case the curve is going to be concave up, right? So it is going to be concave up. So what do we have here? We have local minimum, right? So at x equals to 7 pi by 4. Is that clear to you? So that is how you are going to solve and explain your answer for question number 3. So I hope the concept is absolutely clear. Let's move on and take up question number 4 now. Question number 4. Determine the x coordinates of all the points where the slope of the tangent line to the given curve in the interval 0 to pi is horizontal. So we are given the function y equals to sine x cos cube x in the interval 0 to pi. So horizontal means derivative should be 0, right? So let's find the derivative first. Applying the product rule, we get this as cos x times cos cube x, right, plus sine x times derivative of cos cube x, which is 3 times cos square x times cos x derivative, which is minus sine x. Now we can take something common, which is cos square x we can take common. So we get here cos square x minus 3 times sine square x, right? So this is 3 here, so 3 times sine square x. Now for the critical numbers, now critical number is what? in this case, we want horizontal tangent, right? So the tangent line is horizontal. So that means y dash should be 0 for horizontal tangent. Is that clear, right? So let's find the value. So one value could be, so for y dash equals to 0, we have cos square x equals to 0. That is one option. Second one here is that cos square x is equals to 3 sine square x. Now this second option will give us 1 over 3, and we have tan square x. So let's write tan x and make it square root with plus and minus. Does make sense? So these are the two options for you, right? So when tan x is this, so let's use our special triangles to figure out the answer. So this special triangle, as you know, here we have square root 3, right? 1, 2. So tan is 1 over square root 3. That means we're looking from this side, 1 over, which is pi by 6. So pi by 6 in all quadrants, in all 4 quadrants. So pi by 6 here and pi by 6 there. So that is what it is. Since the interval is from 0 to pi, so we get the value of x as equal to pi by 6 and 2 pi by 1 less than pi by 6, which is 5 pi by 6. Right. As far as the cos zeros are concerned, they are at pi by 2, right? So this is at x equals to pi by 2. Correct? So these are the solutions where the tangent line will be horizontal. So we get an answer as x equals to pi by 2, pi by 6, and 5 pi by 6. Since we are working in the interval 0 to pi. I hope that's absolutely clear, right? Question number 5. If y equals to sin x over x, show that x d2y over dx squared plus 2 dy dx plus xy equals to 0. You can actually pause the video, answer this question, and then look into my suggestions. Now this question could be very complicated, so what we'll try to do here is, as we move along, we'll find each term, write them on the right hand side, and then add them up, right? So let's begin with the given function, which is y equals to sin x over x. Now from here, we can definitely get that x into y is sin x. So first thing which I get here is what xy is, right? So let me write here that xy is equal to sin x. So right, so we have one term with us, which is the third term. Does it make sense to you? Now let's move on. Find the derivative. First derivative, right? So y dash is equal to denominator square, derivative of sin x times x, so I could write this as x cos x, minus derivative of x is 1, so we get sin x. So that is the first derivative, which I could also write here as cos x over x minus sin x over x squared. Correct. So on the right side, I will write what is 2 times the second derivative, right? So let me write here what is 2 times dy dx. So 2 times dy dx is 2 cos x over x minus 2 sin x over x squared, correct? Now let's find this third derivative now. So the second derivative. So differentiating the first term, we get x squared in the denominator. Derivative of cos x is minus sin x times x, so I get minus x sin x. Minus derivative of x is 1 cos x. So that's the derivative of the first term. Next term, let's put minus here. Okay, so that gives you square of square means to the power of 4. Now, so we get x square for sure. Derivative of sine x is cos x. So x square cos x minus 2x sine x. Correct? So which is, let's simplify this. So we'll just write each term separately. So we get the first term as minus sine x over x. The second term here is minus cos x over x squared. Then we have minus cos x over x squared. That two powers cancel. Minus and minus becomes plus, and we have 2x cube is left here, right? So x cube is left here. So we have 2 sine x over x cube. So that's our third term. We need to find x times d2y over dx squared, correct? So we'll just multiply all this by x. So the first term will become minus sine x, correct? Second term will become minus cos x. Now here we have two of these, right? So I am writing 2 here over x, since we are multiplying the two terms, right? So I just added these two to give us that number 2 here. Is it okay? Then we have the third term, which is 2 sine x over x cube. When you multiply by x, we get x square here. So we get plus 2 sine x over x square. Perfect. Now, we need to add the 3. So we have to add these 3 terms. This is our third term, second term, and the first term. So if you add these 3, what do you get? That is what we're trying to figure out. So now we're doing the whole thing, adding all 3. So when you add them, you can see how they cancel, right? So we have sine x cancels with minus sine x, correct? Plus 2 cos x over x, let's use different things, cancels. And also we have the third term, which is minus 2 sine x over x square, which cancels with this, and so we get 0, correct? So that is how you show it, right? So I hope this process is clear, right? So go through it once again. So hence proved. Correct? So I have very limited space to work with you, but I have explained you how to do it. I hope it makes sense. Question number 6. Determine the equation of the normal to the curve square root 2 sine x plus y equals to 0 at 0. So this is a coordinate point, right? So let me use a coordinate point. At this point, expressed in standard form, the equation of line, correct? So we are given the function which is square root 2 sine of x plus y equals to 0. Now let's differentiate with respect to x on both the sides, correct? So what do we get? We get here derivative of sine x is cos x, so we get square root of 2 cos of x plus y times derivative of inside function, which is 1 plus dy dx, right? 1 plus dy dx. Now this is important part, equals to 0. So that is how you actually get your derivative. Now from here, we can isolate this and find the value of the derivative, right? So now this function could be 0. Now we want to find what the derivative is at 0. So we can now write at 0 pi by 4, what is the derivative, right? So we'll just substitute 0 for x and pi by 4 for y. So we get square root of 2 cos of 0 plus pi by 4. And here we have 1 plus dy dx. So we find the derivative from here. This has to be equal to 0. Okay. So in this equation, we get square root 2 cos of pi by 4 is 1 over square root 2, and that times 1 plus dy dx equals to 0. And this is 1, right? So we get 1 plus dy dx equals to 0, or the derivative dy dx is equal to minus 1. Okay? So we get the derivative at x equals to 0, correct? So that is the derivative. We can say slope at x equals to 0. Now what do we need to find? We need to find normal, right? So slope of normal will be what? So slope of normal will be, let's call m perpendicular, will be negative reciprocal. So it is going to be positive 1. And we know that the point here is 0 pi by 4, correct? So we need to write equation standard form. So we can write y minus y1 equals to m times x minus x1, correct? Slope of the normal is 1, and we have y minus y1 is pi by 4 equals to 1 times x minus x1 is 0. Right? So that is what we get. So we can now take all these terms to the right side and write our equation as x minus y plus pi by 4 equals to 0. So that becomes the equation of normal in standard form. Is that clear to you? So that is how we are going to do it. Now let's move on and take question number 7. Question number 7. An observer watches a rocket launch from a distance of 4 kilometers. The angle of elevation theta is increasing at pi by 40 radians per second at the instant when theta is pi by 4. How fast is the rocket climbing at that instance? So let's try to sketch and then we'll solve this example. Okay, so let's say that is the situation. So the observer is at this point, let's call this as O, and that's the angle theta, where the rocket is going upwards. Let's call this distance as y. The fixed distance of point A from O is 4 kilometers. Correct? Now, the angle of elevation theta is increasing at pi by 40. So we are given pi by 40 radians per second. Now that means what? That means it is d theta dt. Is that clear to you? Now this is very important to understand. At times from the units you can find what you are working with, right? At instance when theta is pi by 4. This is at theta equals to pi by 4. Does it make sense to you? So that is what this statement means. How fast is the rocket climbing at this instance? So let y be the height. So we really want to find what is dy dt when theta equals to pi by 4. So this is what we need to figure out. So I hope it is absolutely clear. Now, in this scenario, we can always relate with tan theta. Okay, so y is, or we can say tan theta equals to, let's rewrite. So we have tan theta equals to y over 4, or y is equals to 4 times tan theta. So that is the relation. Finding derivative with respect to time. So we'll differentiate this with respect to time. So let me take this all on the right side and then we'll do. So we have the function y equals to 4 tan theta. And now let's differentiate it with respect to time. So differentiate with respect to time, right? So we get dy dt, right? So that is what we need. So we get dy dt equals to 4. Now derivative of tan theta will be secant square theta d theta dt, since we are differentiating with respect to time. And now we can find what happens at theta equals to pi by 4. So we have dy dt at theta equals to pi by 4. Substituting the value, we get 4 secant square pi by 4, right? Times d theta dt is given to us as pi by 40. Correct? So that is the value. Now, secant pi by 4 is 1 over square root 2, right? So basically, we know this triangle. So, square root 2, that is pi by 4, correct? So this value itself is just square root 2. So we get 4 over 40 times pi, and this value is square root 2 whole square, correct? Now you can simplify this to get your answer. So that gives you the answer as pi. 4 goes 10 times, and this is also 4, right? So we get 4 over 10, or I mean 2 over 10, or 1 over 5 pi, correct? Square root 2 square is 2, so we get 2 over 10, or 1 over 5 pi. So that becomes your rate of change. So our answer here is, how fast is the rocket climbing? So rocket is climbing at the rate of, pi by 5, right? We'll say kilometers per second. So because the units will be kilometers per second, so distance and time at theta equals to pi by 4. Does it make sense to you? So that is how you're going to answer this question. I hope the concept is absolutely clear. Perfect. Now let's take the next application question. Question number 8. The depth of water D in meters of a seaside pier can be modeled by the function d of t equals to 3 over 2. So let's write down the function here. D of t equals to 3 over 2 cos of pi by 6t, where t is time in hours. So meters and hours. Determine the rate of change of depth of water with respect to time at 3 hours. So we want to find the rate of change of depth with time when t equals to 3. Correct? So that is what we need to find. So okay, so let's differentiate this with respect to time. So we get derivative of this as 3 by 2. Cos derivative is minus sine. So let me write minus here. Sine pi by 6t, and inside function derivative is pi by 6. Correct? So let's simplify this. So we have 3 goes 2 times. So we have minus sine pi by 6t, and we are cancelling. Let me just cancel this. So 3 goes 2 times here. So we get the constant as pi over 4. So times pi over 4. Okay? So that becomes our equation. Now we can find the derivative, correct? At this at t equals to 3. T equals to 3. So just substitute 3 here. So we get minus pi by 4 sine 3 pi by 6, which is minus pi by 4. Now sine pi by 2, right? Sine pi by 2 is 1, as you know, so we get minus pi by 4 as our answer. So the answer here is minus pi by 4 meters per hour. Now units are very important in these examples, correct? Let's move on and take the last question here, which is question number 9. Question number 9. A particle moves along a line so that at time t in minutes, its position is sine of t, s of t, is equals to 8 sine 2t. For what exact value of t does the particle change direction in this interval? So we are working in the interval 0 to pi, and we want to find change in direction. that really means that we want velocity to change, right? So we'll find velocity. So as soon as the velocity changes, we know the direction has changed. So let's find velocity is equal to 0, and then we'll be able to figure out when the direction changes. Correct? So velocity of this function is derivative of displacement. So that gives you 8 cos 2t times 2, right? So which is same as 16 cos 2t, which is the velocity. Now, to find the critical number, let's equate this velocity to 0. So we get 16 cos 2t equals to 0. Now, when is this equal to 0? Well, cos is 0 at, within this interval, it will be 0 at pi by 2, correct? So we can substitute pi by 2 here and get our answer, right? So as you know, this function will be 0 for 2t equals to pi by 2. Correct? So that implies that t equals to pi by 4. So that is our answer, correct? Now, so at pi by 4, let's substitute this value. So we know the first answer, which is at pi by 4. Now it's kind of important to understand that this interval is given to us for time, right? So it says change in direction in the interval 0 to pi. Now if you look into the cosine function, let's just extend this a bit. Okay, so it will have actually two zeros here, one at pi by 2. Then we have at 3 pi by 2. That is also 0. Now if I divide by 2, we get this as 3 pi by 4, which is actually less than pi by 2. So we could also take 2t equals to 3 pi by 2, which implies that t equals to 3 pi by 4. So we actually get 2 points here where the direction is going to change, right? So do you understand this part? So those are the turning points. So for what exact value of t does the particle change direction in this interval? So we have two points here. So I'll say here, so the answer here will be at t equals to pi by 4 and t equals to 3 pi by 4, correct? So every time the velocity becomes 0 in this case, it changes the direction. Perfect? So that is how we could actually find the answer for this part. Now the second part is, what is the particle's maximum velocity in this interval? Now to find the maximum velocity in this interval, we'll actually analyze the first derivative, velocity, right? So let's find the derivative of velocity itself, which is acceleration. So acceleration is the first derivative of velocity. We have the expression here, 16 cos 2t will be minus 32, that is 2 times this. Cos derivative is minus sine, so we get minus 32 sine 2t. Correct? So that becomes the derivative. Now to find the critical numbers, we can equate this to 0, right? Which will be 0 for sine. If you sketch the graph, it's easy to sketch the graph, see and explain, right? So there are 3 zeros. Now, when we say t is between 0 and pi, in that case, 2t is going to be between 0 and 2 pi. Now that is why I'm taking two different values. You should understand this part, right? So as far as t is concerned, that is my graph. Now we want that sine 2t to be 0. So there are 3 points where sine 2t could be 0, right? So these are the 3 points. Now, this is a sine function. This is negative, so it goes in the other direction, correct? So as far as our acceleration goes, let me sketch the acceleration part. Okay. The acceleration part will be kind of like this. This is the acceleration part. Is it okay? Where this point is going to be minus 32 and that is going to be plus 32. So what is the particle's maximum velocity in the interval? The question is straightforward though. So maximum velocity will be, we can find will be at, you can say 16, right? But we have to show and prove it. That's the whole idea. So that's what we are trying to do. So the maximum velocity occurs when the rate of change is from negative to, from positive to negative. Do you see that? So when it changes from positive to negative, then we have the maximum, correct? Then we have the maximum. Now here, the critical points for time t being 0 will be at, so we have 2t equals to 0, pi and 2 pi. So these are the 3 critical points. So t is equals to 0, pi by 2 and pi. So these are my 3 critical points in this particular case. So let's find the maximum velocity at all the 3. So we have velocity vt as equals to 16 cos 2t, right? So if I substitute 0, pi and 2 pi, in that case, for 0 and 2 pi, we'll get cos t as maximum, right? So we find that the velocity for 0 is equals to velocity for 2 pi, right? And, t equals to 0 and pi, because 0 and pi. In that case, it is equals to 16, correct? At pi by 2, it is negative. So at pi, it will be negative 16. So we get our result here, maximum velocity equals to 16, and the units here are minutes and meters. So meters per minute. Perfect. And that happens at t equals to, this happens at t equals to 0 and pi. Okay? So that is how you're going to find the solution for the last part. So I hope you find this series interesting and useful. I've taken up one full test paper, 9 questions, which normally take, for which you are given 75 minutes to solve. Now I hope this explanation helps you to understand and review the whole topic. Feel free to write your comments, share your views, and if you also share with me your test papers, I can provide you with their solutions. Feel free to share my videos with your friends. Thanks for watching and all the best.